Hey guys, we're going to be changing gears a little bit today. We are moving from changing fractions greater than a whole to mixed numbers, and from mixed numbers back to fractions greater than a whole, and we are going to be comparing fractions. So remember, when you hear that word compare, you should be thinking greater than, less than, or equal to. Okay? So let's start with a word problem. We have Barbara needed 13/4 cups of flour. Her friend Jeanette needed 9/2 cups. And her friends, Robert, needed 3 6/8 cups. Let's compare the amounts using a number line. So the first thing you'll notice is that we have two fractions that are greater than 1, and we can tell because 13 is greater than 4, Barbara, and then Jeanette, she needs 9/2 cups, and 9 is greater than 2. So my suggestion right away would be to go ahead and convert those to mixed numbers, because when we have a whole number with a fraction, it's a lot easier to plot them on a number line or even to compare them. So that's the first thing I'm going to do, because then that'll help me decide where my number line should start and end, because I don't always have to start at 0 and end at 3 or 4 or 5. Sometimes I can start at 3 and end at 5, or start at 3 and end at 4. So let's go ahead and convert 13/4. Okay, we did this 2 lessons ago. So how many copies of 4/4 can go into 13/4? So let's count by 4s. 4, 8, 12, one more would be 16, that's too many. So 12 copies of 4/4, and then I would have 1/4 left over. Okay, so that would equal 12/4 is equal to 3 wholes and 1/4. Okay, now I believe I'm trying to figure out how to crop this, and I'm having a hard time trying to figure that out. So I'm just going to leave it the way it is. All right, and then we have 9/2. Okay, so let's see, how many copies of 2/2 can go into 9/2? So we have 2, 4, 6, 8, 10. 10 is too many, so I can do 8/2, and I would have 1/2 left over, which means, let's see, 8/2 is equal to 4 wholes and 1/2. So 3 1/4, 4 1/2. Okay, so I'm just going to box the numbers. Let me get a different color here so it's easy to tell. I'm going to be comparing 3 6/8, 3 1/4, and 4 1/2. So this tells us right away, where should I start my number line, where should I end my number line, so that I can compare who needs the least amount of flour versus who needs the most amount of flour. So I have anywheres from 3 cups all the way up to a little over 4 cups. So that means that if I have a little over 4 cups, that I need to go up to 5, but I shouldn't need to go below 3. So I'm going to go ahead and put my number line at the bottom here. And I'm going to start it at 3. Somewhere in the middle, I'm going to put 4. And at the end, I'm going to put my 5. 5 cups. So remember, I have 2 wholes here now. I have from 3 to 4 as a whole, and from 4 to 5 as a whole. Okay, so we're dealing with 1/8, we're dealing with 4ths, and we're dealing with halves. So let's see, if we want to go ahead and plot, let's start with Barbara. Barbara has 13/4, or like we figured out, 3 1/4. So 3 1/4 is a little bit past a 4th. Okay, or I'm sorry, a little bit past 3 1s, or 3 wholes. So if I were to picture that this whole right here is broken up into 4ths, okay, from 3 to 4, it's broken up into 4ths. 3 1/4 would be right here. Now pay attention, when I plot this, I'm not actually going to write 3 1/4. I'm going to write my original number, which was 13/4 cups. Okay? All right, so we plotted Barbara. Now let's go ahead and we'll go right in order of the word problem. Jeanette needed 9 halves, which we said was the same as 4 1/2. So I'm going to jump to 4, okay? And then I know it's 4 1/2, so it's going to be directly between 4 and 5. About right here. And I'm not going to plot 4 1/2. I'm going to plot my 9/12 because that's how it was labeled in the word problem. Okay. Last but not least, we need to plot how much Robert needed, and he needed 3 6/8. Okay, so I know I'm not going to be to 4, because I don't quite have 4 ones yet, 4 wholes, but I'm going to be somewhere between 3 and 4. Well, let's think of, let's see, 6/8. Half of 8 would be 4/8. So right here is going to be my 4/8 spot, but I'm going up to 6/8. So 4/8, 5/8, 6/8, 7/8, 8/8. So let's see, 4, 5, 6, 7. So right here, get my pen to work there. Trying to write super small, is where 3 6/8 is going to go. So now that we have these on the number line, we can go ahead and compare these. So let's start with 13/4. 13/4 is less than 3 6/8, and 3 6/8 is less than 9 halves. We could write a bunch of different statements. We could also write that 9 halves is greater than, let's say, 13/4. Okay, so there's a bunch of different ways that we could write this. All right, let's try another one. 29 sevenths. And I'm just going to put a big circle to remind myself that I am comparing it to 31 eighths. All right, so right away, you guys can see that we have sevenths and we have eighths. It's hard to compare when I have different denominators. So what I'm going to do is rewrite them as mixed numbers, because with a mixed number, it's a lot easier to plot them on a number line and then compare them using our benchmarks, 0, half, and whole. Okay. By the way, if we go back and look at this one, when I say 0, half, and whole, I know it's a little bit trickier because we don't have any zeros on this number line. We have all ones. We have 3s, we have 4s, all wholes. We have 3, 4, and 5. So when we say 0, we mean closer to the whole before it. So we would say closer, we could say that 13/4 is closer to 3, but 3 6/8 is greater because it's closer to, or it's past the halfway mark. We could say it's past the halfway mark. Okay, so there's a bunch of different ways that you can use a number line and use benchmark fractions. So let's go ahead and turn these into mixed numbers. Okay, so how many copies of 7/7 can go into 29? So we have 7, 14, 21, 28. I can't go any higher than that. So 28 sevenths, and that would leave me with 1/7. Okay, so my mixed number is going to be 4 1/7. Okay, how many copies of 8/8 can go into 31? Let's see, 8, 16, 24, oof, and then 4/8 would bring me to 32, and that is too many. So it can go 24/8, and I would have, counting up from 24, I would have 7 more eighths. Okay, and that is going to give me 3 7/8. Okay, and I want you guys to notice something right away. these are the fractions that I can compare now. What's really awesome about fractions when you're comparing with mixed numbers is that the first thing you want to look at is the whole number. What do you notice right away? We have 4 ones over here, and we have 3. Okay, so I have 4 and a little bit of chocolate bar, 4 and a 7th. Here I have 3 chocolate bars and 7/8. Okay, even though 7/8 is greater than a 7th, it doesn't matter. Over here I have 4, and over here I only have 3. So right away you can tell me that 4 is greater than 3. 4 and 1/7 is greater than 3 and 7/8 because 4 and 1/7 is closer to 4 wholes, and 3 and 7/8, well, it's kind of so this one's kind of tricky. You could say 4 and 1/7 is greater because it has 4 holes, and 3 and 7/8 is less than 4 and 1/7 because it doesn't quite have 4 holes. Okay, let's try another one. All right, we are going to do 5 and 7/8. And 5 and 9/10. Okay, put a big old circle in there, so a reminder that we are comparing these. Okay, so hopefully you noticed right away after the last strategy I said is look at your whole numbers right away, because if they're different, you don't even have to look at the fraction. But in this case, we have 5 ones or 5 wholes and another 5 wholes. So now, since we can't compare using our whole, we have to compare using our fraction. Now we have 7/8 and 9/10. Well, 7/8 is 1/8 away from being another whole. 9/10 is 1/10 away from being another whole. So they're really close to both being 6 wholes. But this is where you have to think about the size of the pieces. Okay? Eighths are going to be bigger pieces. Tenths are going to be smaller than eighths. So if we only have 1/10 to go to get to 6, that's going to be a smaller distance away from my whole than my eighth, which means it's going to be closer, so much closer to the 6th than 7/8 is going to be. So we can say that 5 and 9/10 is closer to 6 than 5 and 7/8. Okay? All right, let's do one more and then you'll be on your way. All right, I have 2 and 4/6, and I'm going to compare it with 2 and 2/3. Okay, unfortunately, I made it difficult for you. I gave you 2 whole numbers that are the same, which means they're not going to help us much. Instead of looking at our whole numbers, we now have to look at our fractions. Okay, we have 4/6 and 2/3. Now, if I told you guys to compare these on a number line, you'd have a really hard time. Okay, real quick. We have 2 and a little bit, 2 and a little bit. So that means I can start at 2 and end at 3. Okay, 2 and 4/6. So let's go ahead and break this up into 6. So there's my 3/6. So if right here is my 2 and 3/6, this is going to be my 2 and 4/6 right here. I'm going to plot it up here. Okay. Then if I went ahead and plotted my 2 and 2/3, see if I can just erase my... Two and 2/3. Okay, let's go ahead and erase my half mark. And you guys don't have to do this. I'm just doing it so it's a little bit visually a little easier to see. So 2 and 2/3. Let's see, that's only 1/3 away from being 3 wholes. But remember, the smaller the number on the bottom, the bigger the piece is. So if I tried to divide this up, I'd be about exactly at these 2 spots. Here would be my 2 and 1/3. 2 and 2/3. So what do you notice about this? That these are really close. They appear to be really close. Now, what if you're really not sure? What's another strategy that you could use? Well, hopefully you remember that we can make equivalent fractions. So if you're really, really not sure, the last strategy that I would always try, just to be super sure, is to try and make an equivalent fraction. So is there something that I could do to 2/3 to get it to have a denominator of 6? And your answer should be yes. I can multiply that 3 by 2 to get to 6. So if I just do that to the top, I'm going to end up with 4/6. Hey, what do you know? 2/3 is equal to 4/6. Okay, so this is actually like saying 2 and 4/6. 2 and 4/6, 2 and 4/6. Well, hey, they're equal. So just be very careful of that. All right, I took extra long on this video today, but I think you guys will be able to get through the problem set pretty quick. You do need to give explanations on the problem set. Okay, on the back side, you will need to give explanations for your answers. You can't just say it's greater than, less than. You actually have to say why. Okay, try and say something about a whole or a half. Use your benchmarks. All right, guys, good luck.